Okay, Assalamualaikum and a very good day to all. So in this video, I will show you how to calculate the area of parallelogram and the area of triangle by applying vector product. Okay, let's say we have parallelogram PQSR and the triangle PQR. So the area of parallelogram PQSR is equals to the magnitude of PQ cross PR. Okay, and then the area of triangle PQR is equals to 1 over 2 times with the magnitude of PQ cross PR. Okay, so we look at the example. So given the points A 1, negative 1, 3, B 2, 0, 1 and point C 4, negative 2, 7. So question A, express in terms of I, J and K for resultant vector of AB and resultant vector of AC. So we have point A, point B and point C. So actually point A, point B and point C is in the form of coordinate. So we must know that these three vectors actually are the position vectors, and position vector, please remember that the position vector must start from 0 or starts from the origin. Okay, so if we have point A, actually we can rewrite it as OA. Okay, the position vector is OA. So 1, negative 1, 3. And then for point B, the position vector is OB equals to 2, 0, 1. And same goes with point C. We have OC equals to 4, negative 2, 7. Okay. So for question A1, we must find the resultant vector of AB. So resultant vector, we must know the distance or the direction of the vector. So let's say, okay, so we must find the resultant vector of AB. So we focus to vector A and vector B first. So okay, let's say this is the origin. So vector A, okay, so let's say this is vector A. And we have another vector from the origin, which is vector B. Okay, and then we want to find the resultant vector of AB. Okay, resultant vector of AB. So resultant vector of AB, okay, we must start from point A and then go to the origin, continue to point B. Okay, so AB, vector AB means starts from A, ends at B. So we can write the resultant vector. Okay, A go to point O or origin. So AO continue with plus with the origin to B. So OB. So AO plus OB. Okay, so given in this in the question is vector OA and vector OB. Okay, but we must use AO here based on the resultant vector just now. So AO, we can see here A to O is the opposite direction of OA. Okay, so if OA equals to 1, negative 1, 3, AO is the opposite direction, so it is in the opposite sign. So we must add negative. And then we write the vector OA, 1, negative 1, 3. Therefore, vector AO is equals to negative 1, 1, negative 3. Okay, we expand the negative. Okay, So the magnitude is the same, but the direction is in the opposite direction. So AO is the negative vector of OA. Okay, so AO we substitute. AO is equals to negative 1, 1, negative 3. And then plus OB. So the question given is OB, so we can write 2, 0, 1. Okay, so the direction is the same from O to B. Okay, so plus 2, 0, 1. Okay, next step we simplify. So negative 1 plus 2. Okay, negative 1 plus 2 is 1. And then 1 plus 0 is 1. Negative 3 plus 1 is negative 2. Okay, and then the question wants us to express in terms of I, J, and K. So we have 1 I, so I plus 1 J plus J, and then minus 2 K. So this is the resultant vector of AB in terms of I, J, K. Okay, so we continue with the second question. We must find the resultant vector of AC. So AC is equal to, so from the origin we have vector A and then vector C. So we must find the resultant vector of AC. Okay, so starts from point A, go to O. So we have AO plus continue from O to C. Okay, so AO, okay, we can see here AO is the same as in question A1, is equals to negative 1, 1, negative 3. Negative 1, 1, negative 3 plus OC. So OC is given in the question. We have 4, negative 2, 7. So plus with 4, negative 2, 7. So we have negative 1 times, negative 1 plus 4 is 3. 1 plus negative 2 is negative 1. And negative 3 plus 7 is 4. So rewrite or express in the terms of IJK. So we have 3I minus J plus 4K. Okay. Next question. Okay, next question. By using the vector product, find the area of triangle ABC. So area of triangle ABC is equals to, the formula is (1 over 2) times with, we have AB cross with AC. Okay, triangle AB, AC, magnitude. Okay, we use AB and AC because we just find the value or the resultant vector of AB and AC in question A. Okay, so we already have the resultant vector of AB and AC. Now we must find the cross product between AB and AC. So the cross product AB cross AC . Okay, we write in the form of matrix IJK. Okay, so first we substitute the value of vector A. So vector A we have, vector AB we have I plus J minus 2K. So I 1 plus J 1 minus 2K negative 2. And then we substitute the vector of C. vector of AC. Okay, so vector AC is 3i minus j plus 4k. So 3i minus j plus 4k. Alright, so we must find the cross product of these two vectors. Okay, so equals to, right, so for I, okay, so we have 1 times 4 minus negative 2 times negative 1. This is for I. And then remember the operation or the sign is plus minus plus. So minus with, okay, so for j, we have 1 times 4 minus negative 2 times 3. This is for j. And the last one, we have k. So for k, okay, plus 1 times negative 1 minus 1 times 3. Okay, and then next, we simplify. So for the first value, for I, we have 1 times 4 minus negative 2 times negative 1 is equals to 2i. And then minus 1 times 4 minus negative 2 times 3 is 10. So minus 10j. And then plus 1 times negative 1 minus 1 times 3 is negative 4k. So we simplify. Okay, so we have for the answer is 2i minus 10j minus 4k. So this is the cross product of AB and AC. Okay, back to the formula. Okay, we already find AB cross AC, and then now we must find the magnitude of AB cross AC. So the magnitude of AB cross AC, okay, AB cross AC, the magnitude is equals to the square root of 2 square plus negative 10 square plus negative 4 square. Okay, so the formula, remember the formula of the magnitude is equals to square root of x square plus y square plus z square. Okay, the formula of magnitude. Okay, so we simplify. The magnitude of AB cross AC is equals to square root of 120. Okay, and then back to the formula. After we get the value of the magnitude of AB cross AC, we must multiply with 1 over 2. So the area, okay, so the area of triangle is equals to 1 over 2 times with the magnitude of AB cross AC. So we substitute the value of magnitude. So 1 over 2 times with square root of 120. So we get the answer is 5.48 unit square. 48, and then for the area we have unit square. Okay, so this is the answer for question or example 17. Okay, so next example. PQRS is a parallelogram relative to the origin O. The position vectors of PQR and S are I plus 3j minus k, 2i plus 4j plus k, 6i plus j and 5i minus 2k respectively. So show that QP is cross QR is equals to negative 5i minus 9j plus 7k, and by using the result in A, deduce the area of the parallelogram PQRS. Okay, so given the position vector of P, Q, R and S, so this one is for P, this one is R, sorry, this one is Q, and this one is for R, and the last one is for S because of the word respectively. Okay, but this is not the PQRS only, but it is the position vector. So the keyword here is the position vector. So actually this is OP, okay, must start from the origin, OQ, OR and OS. Okay, OP, OQ, OR and OS. So question A, show that QP cross QR equals to negative 5i minus 9j plus 7k. So first we must find the resultant vector of QP and QR. Okay, so question A, QP. Okay, so we focus to vector Q and P. Okay, so QP origin to vector Q and another one is vector P. So we must find the resultant vector of QP. So we must start from Q to O. So QO plus OP. Okay, so we can see here the direction of vector QO is in the negative direction of vector OQ. So we can write negative and then QO, substitute the value of vector OQ. So we have 2i plus 4j plus k. And then plus with OP, so vector OP, okay, we have I plus 3j minus k. So we simplify or we open the bracket, we expand the negative outside here. So we have negative 2i minus 4j minus k. And then plus with I plus 3j minus k. So we simplify, we have negative 2 plus 1i is negative I. And then negative 4 plus 3, 4j, negative 4j plus 3j is negative j. And negative k minus k is minus 2k. So this is for vector QP. Okay, next we must find vector QR. Okay, so vector QR. Okay, QR is equals to, so we have the origin, vector Q, and another one is R. So the resultant vector of QR is equals to QO. So QO plus with OR. Okay. So QO is in the negative direction, in the opposite direction of OQ. So we must put negative and then substitute vector OQ. So 2i plus 4j plus k. So 2i plus 4j plus k. Plus with OR. So vector OR is 6i plus j. So 6i plus j. Okay, and the next step we expand. So we have negative 2i minus 4j minus k plus 6i plus j. And the last step, we simplify. So we have negative 2i plus 6i, 4i, negative 4j plus j minus 3j, and then minus k, so minus k. So we have 4i minus 3j minus k for vector QR. Okay, back to the question. So we must show that QP is QP cross QR is equals to negative 5i minus 9j plus 7k. So we must find the cross product of these two vectors. Okay, so we have QP cross QR. So we have IJK. So first, substitute vector of QP. So QP just now is negative I minus J minus 2K. Okay, negative I minus J minus 2K. And then for vector QR, we have 4i minus 3j minus k. 4i minus 3j minus k. Okay, so we find the cross product. Okay, so we have for I, right? So for I, we have negative 1 times negative 1 minus negative 2 times negative 3. Okay, cross multiplication. Okay, cross, so this is for I, and then minus, okay, plus, minus, plus. So minus for J, so we have negative 1 times negative 1 minus with negative 2 times 4. So this is for J, and then plus with, okay, for K, we have plus with negative 1 times negative 3, and then minus with negative 1 times 4. IJK. Alright. So we simplify. Okay, so negative 1 times negative 1 minus minus negative 2 times negative 3. We have negative 5. I. And then minus negative 1 times negative 1 minus negative 2 times 4 is 9. So this one is 4K, 4J. And then plus negative 1 times negative 3 minus 1 times 4 is equals to 7. Okay. Alright, sorry. This one we have, okay. For K here, we have negative 1 times negative 3, and then minus with negative 1, here. Minus with minus negative 1 times 4. So, okay, negative 1 times negative 3 is 3. Minus with negative 1 times 4 is negative 4. So, we will get 7K here. Okay, sorry. Alright, so we get the answer for QP cross QR is equals to negative 5i minus 9j plus 7k. So back to the question. Okay, so we get the answer the same as in the question. Negative 5i minus 9j plus 7k. So we should. Alright, so this is for question A. Okay, next question. By using result in A, deduce the area of the parallelogram of PQRS. Okay, so the area of parallelogram parallelogram is equals to the magnitude of QP cross QR. Okay, so QP cross QR is this one, negative 5i minus 9j plus 7k. So we must find the magnitude of QP cross QR. So square root of negative 5 square plus negative 9 square plus 7 square. We get the answer is equals to square root of 155. Okay, so square root of 155 is equals to 12.45. So the area is unit square. Okay, so this is the area of parallelogram. Okay, so that's all for this video. Thank you very much.